Welcome to Study Loop.
So given the equation minus IR minus L di dt minus Q over C is equal to 0, if we multiply through by minus I, we get that I squared R plus L times I di dt plus Q times I over C is equal to 0. And from here we can immediately see that this first term is the power through the resistor, or the rate at which energy is dissipated through the resistor. Let's look, so if that's the rate at which energy is dissipated through the resistor, let's look at the rates at which energy is dissipated through other components of the circuit. So the rate at which the energy stored in the inductor changes, dUL dt, is equal to d dt, and we know the energy stored in the inductor is a half times L times I squared. And this is simply a half times L times d dt of I squared. And this is equal to a half times L times 2I di dt. And hence we are left with L times I di dt. And we can see that this is the second term. So this is the rate at which the energy that's stored in the inductor is changing. So we'll call that PL, the power of the inductor. So we're left with one more term. And let's assume that's the rate at which energy is changing through the capacitor, duc dt. And this is equal to d by dt. The energy stored in the capacitor is q squared over 2c, where c is the capacitance of the capacitor. And this is simply 1 over 2c d dt of q squared. And this gives us 1 over 2c times 2q times dq dt. And dq dt we know is the current I. So this gives us q times I over the capacitance C. And that we can see is the third term. So that's the rate at which energy is changing through the capacitor. So we'll call that PC. So what we can see from this equation is that PR plus PL plus PC is actually equal to 0. And this equation says that the net change of energy in the circuit is 0, or the net rate of change of energy in the circuit is 0, and that at any given time, one of either PC or PL is negative. So if the current and UL are increasing and the charge are increasing, then the charge on the capacitor and UC are decreasing, and vice versa.